gentlemen, join me in welcoming Dr. Jairaj Joseph from the Healthcare Technology Innovation Center in Chennai, India. Welcome, Doctor.
Thanks, Dave. It's a great honor, and it's very wonderful to be here in this amazing stage.
Well, as I mentioned, there are major healthcare issues around the world, but certainly big ones in India. Can you give us a sense of the magnitude of that?
Yes, Dave. As you were mentioning, India is the second most populous nation in the world. And with it, huge population comes its own set of challenges. So providing quality healthcare at the right time to its billions is a very huge, daunting challenge. And added to that, the fact that we do not have enough number of doctors, we are scarce in terms of resources, both skill as well as infrastructure. So the problem becomes even more difficult. And just to make it a bit more difficult, now we are seeing a slight change in the disease burden. So we are seeing a change in disease patterns going from the epidemics or communicable epidemics to a much more wider impacting non-communicable lifestyle diseases. So we are talking about upwards of 130 million people in India suffering from this kind of diseases. So that's the magnitude of the challenge that we have in Indian healthcare.
Well, that's a big challenge. How do you even begin to approach that?
Yeah, so, well, at Healthcare Technology Innovation Center, IIT Madras, from where I come from, we try to address these challenges by developing technologies which mitigate the barriers of, number one, cost, mitigate the barriers of skill so that you can use technologies very easily, and finally create technologies which are scalable. So we are trying to develop technologies that are affordable, accessible, and scalable. And this is not easy. So you need a lot of people to help you in that. So with that in mind, we have actually created one of the largest medtech innovation ecosystems in the country, wherein our engineers, our researchers, and people talk to the government, or I would say various government agencies, and who provide support to us. And then we provide this platform wherein you can talk to about like a variety of clinicians, doctors, nurses. So all this talking leads to a lot of interesting ideas where people understand what is a problem, and then they try to come up with innovative solutions. So we take these solutions, we go back to the field, validate them, and finally we work with industry to transfer this technology into products which ultimately scale. Now, we are in healthcare, so we mostly work with healthcare industries, GE, Becton Dickinson, etc., to name a few. But we are really proud to have National Instruments as a technology partner who is providing us with the right set of tools which allow us to quickly convert our concepts into reality.
I see. Now, cardiovascular disease, of course, is one of the world's biggest issues, and I can imagine it's a big issue in India. How big is it?
Well, I don't need to tell anybody about the size of cardiovascular disease impact in India. About 10 to 15% of the population, which means upwards of 120 million, are affected. And the biggest challenge that we have is how do we come up with effective technologies for screening this huge number of people, so that we can at least identify at-risk subjects and then provide timely intervention. The stiffness of your blood vessel, as your heart beats, your arteries expand and contract. So they are compliant. So if you lose that elasticity, it means you're in trouble. So that stiffness is a very good marker which can be potentially used for cardiovascular screening. However, the state-of-the-art technology which is currently available for measuring stiffness requires an ultrasound imaging system. Now, that has to be operated by a trained, certified clinical operator. Now, this means that, unfortunately, we cannot use this technology for screening. So that's a challenge that we have now.
Yes, so you've got to take on large-scale screening, and it's important. How do you begin to do that?
Yes, so we at HTIC have developed a technology called ArtSense. It's like sensing the artery. So it is a technology which uses an image-free ultrasound technique to non-invasively measure how stiff your arteries are. So I can explain the concept, but I think, can I try it on you, Dave?
Let's give it a try.
All right, come. So please have a seat. So what you're going to do is, I have a small transducer here. It is a single element ultrasound probe. I had to put some gel on here. And I'm going to keep this on his neck and on the artery. Let me first check out whether he has a carotid artery or not. Okay, just cool. Uh-oh. Okay, fine. All right. Wow, you have a cool cucumber. Yeah. I'm not sure about me. He has a good heart rate. My hands are shivering. So let me try it out. You see, yeah, the system sends high frequency ultrasound into his body, and then when I orient the probe, it basically, the algorithm searches for the echoes coming from the arterial walls. And after a while, it is basically, it tracks the motion of the walls and gives me a set of cardiac cycles, and finally it tells me how stiff it is. So let me take a look at it. Okay. Okay. If I'm not intruding, how old are you, Ray?
2 days ago, I turned 52.
Wow. Yeah. Your stiffness value is somewhere around 6 to 7, and for that age, wow, you're absolutely healthy.
Excellent. Well, that's good news for me. I guess it's a double cheese pepperoni pizza for me tonight.
Yeah, of course.
I'll have the house salad with you.
All right, that would be great.
Okay, so you're putting some incredible technologies inside a device like this that can actually, in under a minute, with a non-skilled operator,
Yeah.
you're actually pretty skilled.
Let's do it.
But give us a reading on arterial stiffness that people could spread out throughout the world. What technologies are you building on?
Yeah, so this ArtSense device is built upon a variety of NICE technologies, and it is built based on the work done by a lot of people, a lot of engineers, clinicians, faculty also, who got involved. So early on, we used NICE PXI chassis to create a functional prototype inside the lab, and at that point of time, we were actually using transducers that I borrowed from the non-destructive evaluation lab used for metals. So with that system, we created a functional prototype, and then anybody who walked into our lab was a guinea pig. So we started creating a lot of data, we generated all the signals, and we are talking about big analog data. Well, we are not that big, but still we created a lot of data, which then allowed us to create an intelligent set of algorithms, which will understand the nature of the arterial wall dynamics from the signal and do the measurement automatically. Now, while this was going on, we had a set of, we had a parallel track of technology development, wherein we went from the PXI to a desktop form factor, then used USB digitizers, and finally, the latest version that you see here works on the NI-SOM device. So this has allowed us to take our concept all the way from idea, all the way to prototyping, and now we have made various set of prototypes which has been validated by our clinical collaborators. So this technology has been validated on more than 1,500 subjects by 4 of our clinical collaborators in multiple clinical, home, and even field settings. So that kind of approach gives our collaborators the confidence to work with us, and that strengthens our relationship.
So you used our data acquisition to collect that big analog data into a database, do algorithm engineering to create a gem of an algorithm that you're able to then go and deploy on our system on module that could spread around the world in India. That's incredible. So creating something like this with such success, what advice and what change in perspective have you had?
Yeah, I'm not that old to give advice, Dave, sorry. But let me give a perspective on the NICE technologies. So we've been using LabVIEW stuff and NI hardware and software for quite a while, and we are getting greedy. So we want to do more, and we want to do it much faster. And in terms of hardware, because we work on a variety of healthcare applications, we would love to really have those smart edge devices way bit smaller, so that I can actually put it all across my industrial plan, which is actually my human body, and really create a set of connected networks, connected sensors, and to basically add on to not just your industrial IoT, but I would say healthcare industrial IoT. And in terms of, as a closing remark, based on our short experience in healthcare innovation back in India, one thing we realize is that creating scalable, sustainable innovation requires integration of entrepreneurship along with innovation. So realizing this, we are now setting up a medical technology accelerator and business incubator in our center in Chennai, in IIT Madras. So we are planning to open up our innovation ecosystem to the young minds, to the budding startups and entrepreneurs, to allow them to interact with the ecosystem, understand the problems, create technology solutions, and finally, we are also equipping them with the latest technology tools through our partnership with National Instruments, through Planet NI, to enable them to quickly conceptualize, prototype, test, validate, and finally deploy these solutions into the market at a very, very early stage. So I see a bright future. HTIC and NI is all set to create a sea change in the way healthcare technology is delivered in India.
This is great. So you are connecting to the world, taking on one of the biggest healthcare issues out there. What advice would you give to anybody doing something like this?
Well, like I said earlier, Dave, I mean, I'm not old enough to give advice. All right? But let's just tell one thing. Like my previous speaker, be passionate, believe in what you're doing, and of course, my lasting message is still, innovation is very important, but innovation plus entrepreneurship. That's the way forward. That's the way you can really scale impact and create a huge impact.
Passion, platforms, engineering, taking on big issues. Dr. Jayraj, we want to thank you so much for coming and sharing this advice with us, sharing this wonderful device. We want to thank you for doing your part in making the Internet of Things. Thank you.
Thank you very much.